Cubit serves as a demonstration of quantum probability. So as you can see, there is a 5-volt laser connected to a power supply, but currently it is using USB power. It first goes through the first filter, which ensures all light past this filter is polarized to the same angle. This rationale will be explained later. After passing through both filters, the light then goes to a photoresistive sensor that sends an analog signal to the Arduino. Then a Python script forms a serial connection between the computer and the Arduino through the script. After connecting, the computer can control the Arduino. The Arduino is also able to send serial data to the PC directly. So after running the Python script and connecting to the Python script, the Arduino starts to calibrate and send data. So as you can see, the data has just came in from the server. And from here, we can see that we can flip a coin and it uses that probability from the sensor to create a coin flip. So the sensor essentially goes through the midpoint, and through the midpoint is able to map either a 1 or 0 that corresponds to a heads or tails on the coin flip. My entire project is based off of Malice's law. Malice's law describes how the intensity of light transmitted through a polarizer depends on the angle between the light's polarization, direction, and the transmission angle, and effectively explains the nature of polarized light. The following are the metrics of Malice's law. The first one is I0, which is the initial intensity of the light before passing through the filter. Theta is the change in angle between the initial angle of the light and the filter that it goes through. I would be the final output intensity of the light after passing through the filter. And by plugging in the figures into Malice's law, we can see that a 45-degree filter will cut off exactly half of the light and resulting in half the intensity in the output. Going in terms of quantum mechanics, this intensity is equivalent to the probability of photons passing through the 45-degree filter. This is where we go into Born rule projection probability. As we can see, Born's rule is identical to Malice's law, with the intensity being a probability figure instead. Thus, the half the photons emitted will pass through the secondary filter and into the sensor and produce a 2 outcome measurement. Either a photon is detected or a photon isn't detected. However, the current sensor I am using returns a continuous intensity. It's a range, it's an analog value between 0 and 1023. Thus, a midpoint threshold is required to map the continuous intensity into bits. Through the following code, the future sensor readings can now be mapped to either a 1 or 0 using this calibrated midpoint mapping. All in all, this was a very fun attempt at exploring quantum mechanics and physics within my home using a 3D printed setup. One problem you may have noticed is that the range received by the sensor is nowhere near a 50% probability for a 1 or 0. That is a problem I want to address in the future using a more robust setup as well as more accurate sensor readings.